This is a nozzle. It consists of a cylindrical shell and a short tube inside. The internal short tube can spray water upward. The orange one is a ball that sank underwater. When the short tube inside sprays water, if the ball is far away from the nozzle, so the ball will be pushed away from the nozzle. And when the ball is relatively close to the nozzle, the ball will be sucked by the nozzle. So why is the ball being sucked by this nozzle? Some people explain that because the gap between the ball and the nozzle is small, so the speed is high, so the pressure is low. So the ball was sucked by this nozzle. Are these people's explanations correct? I don't think they're right. The actual reason is as follows. As indicated by the blue arrow, when water is sprayed from the short tube of the nozzle, the sprayed water will leave the nozzle area through the gap along the ball. Not only that, as indicated by the red arrow, due to the viscosity of the fluid, part of the water inside the cylindrical shell will also be carried away by the water sprayed out by the short tube, leave the nozzle area. This leads to a decrease in water pressure inside the cylindrical shell, below the ambient pressure outside the nozzle. So the ball will be sucked by the nozzle. When the distance between the ball and the nozzle is relatively large, the gap between the ball and the nozzle shell is relatively large. At this point, although the water inside the cylindrical shell will still be carried away, but water outside the cylindrical shell will flow back into the shell. As a result, the pressure inside the casing will not decrease. Therefore, the nozzle cannot suck up the ping pong ball. Not only that, the force of the sprayed water will also push the ball away from the nozzle. And if the gap between the cylindrical shell and the ball is too small, so the pressure inside the nozzle will increase. Above the ambient pressure outside the nozzle, the ball will be pushed outward by the nozzle, so the gap between the nozzle and the ball cannot be too small. So even if the gap is too small, the nozzle cannot generate low pressure.